Hi friends, now let's begin our journey into solving this deadlock problems. The previous session we have seen that there are four ways of solving this problem. So let us attack the first way of solving the deadlock problem, and that is what we call deadlock prevention. So for a deadlock to occur, we require all four Kaufman conditions to be true. What are they? 1. Mutual exclusion. That means the resources should be allowed to be used by maximum one process. So maximum one process should be allowed to use any resource. So if a resource is being used in the shared manner, then anytime only one process can use it. Mutually exclusion. Second, hold and wait. That means we are allowing the processes to hold some resources and waiting for the resources that are not currently available. So that is another reason why deadlock can happen. And the third one is no preemption. That means the resources which are held by any process are not being released until that process completes its job. And if that process is in turn waiting for some other resource which was held by other process, then till that resource is available it cannot continue, and if it cannot continue then it cannot complete, and if it cannot complete then it cannot release the resource. So there is what no preemption is mean. Yeah, that is another reason for deadlock. And the fourth is the circular wait. So there is a circular wait. First is waiting for the second is waiting for third to complete, third process is waiting for the fourth to complete, and fourth in turn is waiting for the first process to complete. Till fourth completes, third cannot complete, till third completes, second cannot complete, till second completes, first cannot complete, and till first cannot complete, fourth cannot complete. So that cycle is there. They depend on one another in a cyclical way, and hence none of them can continue their work, and hence deadlock. So all four conditions have to be met simultaneously, only then there will be a situation called deadlock. The deadlock prevention is something which makes sure that at least one of these four conditions is not met. Either there should not be mutual exclusion, or there should not be hold and break, hold and wait, there should not be no preemption, or there should not be a circular wait. If one of them breaks, then definitely there won't be any possibility of a deadlock situation. So that is what is the goal of deadlock prevention. Let us see how we can target each of these so that we can prevent deadlock. So first one, mutual exclusion. What if we deny mutual exclusion? So first thing is it is not that easy, because mutual exclusion is introduced into our system to ensure that there is no race condition, because we are allowing more than one process to share the resources, and when they are being shared, then we don't want the data to be corrupt, inconsistency in the data, inconsistency in the work. So to ensure that race condition doesn't occur, we want mutual exclusion. What if we deny? Can we? So that's what we need to look at it. So the goal is now allow resources to be shared. So instead of saying that this resource maximum one process can use it, now can we say that more than one process can also use it? If so, then allow it. Then when can we do that? So this can be done when you can allow multiple processes to use the resource only in the read-only mode. Read-only mode, if you allow multiple processes to work, it is safe, no issue, because it's only going to read. So a single resource information can be read by multiple processes simultaneously, and that definitely is not going to create any problem unless until you allow some process to write on that. So as long as it's only reading action, not doing anything after reading that, so read the information, modify the information, write back, no, such things are not allowed. We try to see that. So when you are trying to say increment a value of a variable, then we read the content of the variable, increment the variable content, and then write it back. So read it, increment, write it, and while doing this, if other process enters in, then it's going to create inconsistency. So to have that, make sure that such thing does not happen, we implemented mutual exclusion. Some locking mechanism we created and made sure that anytime maximum one process can use this type of shared resource. But yes, if it is only reading, not doing any other thing, just reads it, uses it, doesn't write back or something, of course no issue, so we can allow them. But there is limitation, and it works only for shareable resources like files or memory, that where you can just read the files. So there are some files which are only in the read only mode. Okay, you can allow all the processes to open the files, read the contents, because the file itself is locked in the read only mode, nothing is allowed to write on that. Then there is no problem I can see if you allow more than one process to read simultaneously. Yeah, that way you don't have to say that if one process is reading the file, others should wait. No, we can allow all simultaneously, concurrently to read. Of course, only read only. But most of the resources like printing, disks and all that, they need exclusive accession, and hence it is not always practically possible. Yeah, that's what wanted to claim, that only few cases that is possible can allow multiple process to share simultaneously under only read only mode. But most of the time, say when you say printer, it is not nothing to do with reading, it is writing. So our process tells printer to print something, then it is writing onto the printer, and when it is writing, then you should make sure that any given time only one process should write onto the printer's buffer, otherwise the whole garbage comes out of the printer as a printout, so nothing makes any sensible prints. Therefore make sure that any given time only one process is allowed to print its document, don't allow more than one process any given time to print. So such issues, when we have such problems or such resources, then definitely we cannot share them, and it is practically not always possible to deny mutual exclusion, because it's going to create a major problem, that is the race condition. So let us forget about denying this first condition, mutual exclusion. Very rarely it is possible to read only operations, so it's okay, but not a foolproof way of solving the problem. Next, deny, hold and wait. So the goal here is let's not allow process to hold some resources and wait for other resources. Now, how can we do that? So what we can do is a process must first request all the required resources at once. So before beginning, it should give a list of resources it wants, and if all the resources are available, then it will be allotted and the process continues to work. If even one is not if one is not allowed, one is not available, then none of the things are allotted, and hence that process has to wait. So the process which could not get all the resources required keep waiting, but definitely not that some resources are acquired and waiting for some other thing. Such situation does not occur, and that way we can ensure that there won't be any deadlock situation. The positive side of this is it avoids deadlocks by not allowing this wait while holding, but there is a negative side of that, and it leads to low resource utilization. even if one of the resources is not available, then all the resources which even are freely available will not be allotted to the process, and hence most of the time resources lie idle. Even if they are free, there is no process to take up, because among all the requested resources, if one resource is not available at that time, then all others also are not useful to the process and their allotment is denied. Therefore, there is very low resource utilization, and it may happen that every time one or the other resource is not available, therefore it will never get a chance, or will never get a situation where all the resources are available at the same time, and hence will get an allotment and hence can continue. So it may so happen that a process may keep starving all the time, or even may not starve but may have to have a very long waiting time. So that is the negative side of denying hold and wait. What if we go for the next one, deny no preemption? So here the situation was, some were held by the process and that process is waiting for some other resource. Some resources are held by the process and that process is waiting for some other resource. In this case, what we can do is we can forcibly take away these resources from this particular process, because anyway till it gets the other process which it needs, we cannot continue with the process. The process has to wait, and when it is waiting, then what is the purpose of keeping these resources with it? So let them release. So let the resource be released, let the process release the resources, and these resources may be useful for some other process, and that way we can ensure that there is no deadlock. So what we can do is, if a process is holding some resources and request for another, and that request is denied, then it must release all its current resources. So it is, a process is holding some resources and then it wants one more, and that one more is not available currently. Then instead of waiting for that one more, what we can do, all others which are already with us to be released, so that it can be useful for other processes, so that the overall system continues to run, no deadlock can occur. So here the process which is preempted will be placed back in the queue. So when it gets next time its chance, then it will again request for all the resources whatever available. So one by one, one by one, one by one it will get. The moment it finds one is not available, then whatever it has acquired, released. So that's how it works. So usually the CPU, we have seen in the scheduling problems, if a preemptive scheduling is done, how it is working. Same way, memory pages we can preempt and make other processes to use them. So this memory pages details and all that we look in our next module, where we are dealing with memory management and all that. So let's look at this situation again when we are working on memory management, paging system and all that. So the negative side of this is not suitable for non-preemptible resources like printers, files and all that. So when you are writing something onto the file, one process was writing something, and while writing something on the file it wanted some other resource, and that resource was not available. Then this file writing process is stopped and it is released, and that incomplete file is made available to others. Definitely that file is in inconsistent state, and hence it is going to definitely create problems to the situation. Whole system will be under a problem. So cannot allow this non-preemptible resources go for preemption in this situation. So it is again not a 100% solution. Every time we can take up this and break the no preemption condition and ensure that no deadlock occurs. So not always guaranteed. Therefore, let's check what if the Next one, the other problem we have is it may lead to rollback, extra overhead, and definitely data inconsistency is confirmed. So whenever preempt it, it goes back to the queue. When it comes back, then it has to get back all whatever was done earlier should be rolled back and restart everything. So lot of overhead we have. Then finally, the last condition, don't allow the last condition to occur, that is deny the circular wait. So goal is to prevent circular chains of resource holding, and the method used is impose some global ordering for resource types. So there are resources, so each resource, let us give some labels to them, some ordering to the resources, types of resources, and here the processes should be allowed to request in an increasing order of enumeration. So some way, some rules are imposed so that we don't get into this circular wait situation. So how it is done? So resources are numbered as R1, R2, R3 and so on, and a process holding any resources, say R1, now can request for R2 or R3 or R4 only. So only the higher one but not the lower one. Say the current a process P1 is holding R5. Now after holding R5, it can request for R6, R7, R8 and all that, but definitely not R4, R3, R2, R1. So if it is holding R5, then R1, R2, R3, R4, it cannot request. So this way what happens is it can only look forward, it cannot look backward, and because of this we can ensure that there is no circular wait. So the positive side of avoiding this condition is it is simple and very effective, but the negative side is requires careful numbering and tracking of resource requests. So numbering the resources is one side, and then tracking the request resources. So this is going to create the overhead, it is going to have a lot of overhead. So we waste most of our time in working on the numbering and tracking and all that than actually working on the real problems. So that is the negative side of denying the circular wait. So overall, if you take a bird's eye view, deadlock prevention, so we have 4 conditions which all have to be met for a deadlock to occur. So if we can avoid at least one of them, if you can ensure that one of the condition fails, then we can prevent deadlock to happen. So mutual exclusion, the technique is use shareable resources, allow more than one process to use simultaneously. So practically it is not that a good idea. The drawbacks not applicable to all cases. Yes, hold and wait condition, if you want to break it, then allocate all at once. So all the resources should be allocated at the beginning. So that way what happens is either all the resources will be made available or none of them will be made available. Therefore this holding and waiting is not possible. So either they will hold all resources and continue execution, or hold none and wait. So that way definitely no deadlock possible. The practicability is medium. The drawbacks, low utilization and possibility of the starvation. The third condition to break is no preemption. So preempt resources on the request denial. The practicality is medium, hard for non-preemptables. So when it comes to non-preemptive resources, then it cannot be applied to them. And finally break this fourth condition, that is the circular wait, by imposing resource ordering, and it's having high practicality, and here the system requires system-wide policy. So there are the drawbacks of this. So this is overall 4 ways this problem can be prevented, either saying no to mutual exclusion, or saying no to hold and wait, or saying no to no preemption, or saying no to circular wait. So if any one of them is said no, then definitely make sure that there won't be any deadlock. So hope you enjoying these sessions. So please make sure to like the videos. Please do comment you have anything to say about our videos, any extra things you require, and please share these videos with your friends. Subscribe to the channel and please press the bell icon to get the notifications about the forthcoming sessions, videos, and so on. So that's it for now. Thank you.